14-meter overpass. Don't let boats hit your bridge. Try building over it. So the new mechanic that they're showing you here is that you've got sort of a central anchor point that you can build your bridge on top of. Also, you've got a boat here that interferes. If you just try to build road all the way across, well, first of all, you're ending up a little bit short. So you can't quite build road off to that last one. But, even worse than that, this road goes right through the boat. So if you try to... I don't know why it's whining at me about, oh, you can't build there. Alright. So a couple things are going to happen if we try to simulate this. The weight of the road itself is going to pull itself down, and because road is not great in tension, the road is just going to break. One of these segments, sort of at random, is going to break because the road cannot handle the tension forces that are created by its own weight pulling it down. So let's just show that real quick. Right? How about at 20% speed, just so you can see? Boom. It's already cracked and broken. But even supposing that we built some Warren truss over top of this, do I have triangulate on? Yeah, I do. I'm going to copy this. And then we'll just do a few more little things here. I think I still have auto triangulate on. Yeah. Alright, so this bridge will almost certainly hold its own weight. Very, very likely it will. But watch what happens when the boat comes through. Down she goes. And the monster truck goes in the drink. Oh, look at that! It's climbing over. Is it going to backflip? Oh, wow. Can we speed this up just a little bit? There we go. And it gets stuck there. Well, that was fun, but yeah, quite the fail. So, I think it's time to introduce a new tool, which is the arc tool. The arc tool allows you to place things, multiple segments of member or structure in an arc. You draw the arc first, and then you and then you select a material, and then you press a button to just make the game automatically. So here's what I think we should do. We should do basically a straight bridge until somewhere just above this. Well, first of all, let's just hold right-click and draw and delete all this. Delete. All right. So here's what I think. We'll do some wooden, we'll do an auto-triangulated wood right here. Hang on, is auto-triangulate off? No, it's on. Okay, so this is kind of an annoying problem. Here's what I'm going to do. I'm going to start with some road, and essentially this is just as a measuring tape to figure out how far out here we can go. And maybe I'll turn on the grid, just so we stick to grid. So it looks like we can go all the way to there. But maybe we don't want to, because I'm thinking if we go here, right, and then we have to do a big arc over here, that might still hit the boat, unless we make that arch really, really steep. Maybe not steep enough for this to go up and over. So how about instead, we will actually delete this, and we'll stop right there. Now, to support this from underneath, wood is very strong in compression, so we should probably just be able to do that. And that should actually support it fairly well. However, we're still going to need to put a truss over top of this just to get us to this point, because right now, This is what's called a pin joint. The things that are attached to it can rotate around it. And if I play this for you, you're going to see this piece of wood is just going to lever right over this way and fall in. So clearly that's no good. We need a truss on top of this to keep this rigid and to handle the downward forces that not only its own weight, but also the monster truck put on it. So auto triangulate is on. Let's get wood, because I think wood is going to be good enough for this. And let's turn the grid off with G, so we can get these as big as possible. And we want, again, I'm going to go at 60 degrees. And good. Can we triangulate to the next one, staying level? Looks like we can. And the next one, okay, so we've got a nice worn truss. Not perfectly symmetrical, but pretty good. And I believe that this piece of wood now, because this is now stiff and rigid, because of the truss on top of it, the downward forces will be straight downward, and this will not be able to fall off to either side. If this tries to lever off this way, it's going to be prevented by the tension here. Likewise, if it tries to lever off that way, because this is rigid, it won't be able to do it. So let's hit spacebar and see what happens here. Stresses are quite low. Yeah, got to like 45% top. So this is quite good. I'm quite happy with that. Now we need to get out our arch tool and build an arch up and over the path of the ship. So here's the arch tool down here. As you can see, you can just hit 9 on the keypad to get your arch tracing tool. We'll go back over here, we'll do 9. And now I'm going to click here, and then I'll just shoot the arch right over to here. And after we click in and place the other end of the arch right here, it'll give us some little tools, some little handles to tweak the arch if we want to tweak it. So now we can grab a hold of these little circles, these little handles, and mess around with the arciness of the arch. You can see we can do some crazy stuff here because this is actually a spline. I'm going to move these apart from each other to make it a little bit flatter. And I'm going to try and make this maybe just a little bit above the boat. The road does have some thickness to it, so you cannot do like that and get it super close because the thickness of the road will actually hit. But you can take it just a little bit above. There's a delicate balance here moving these handles where if you move them way out here, you can see that it gets very steep right here at the end point. But then if you move them too close, then it gets a little bit steep in the center. So you kind of have to... It's kind of a feel thing. Luckily, we have a big truck with big wheels and a lot of horsepower, so it can climb very steep slopes. I'm sure that's why they gave this to you in this level. You know, I'm going to go ahead and put regular road in here right this time, but it may turn out that because of the extra stress caused by the arching nature of this, we may need reinforced road, but we'll try regular road. So I've got my arch laid down, I'm selecting regular road, and now I'm just going to do this fill, which is the 0 on my keyboard, and it'll just throw road all the way along this. So typing 0 now. You can see the thickness of the road is already hitting the boat here. So clearly I screwed up when I was tweaking this with my handle. So I'm going to hit undo or Z to go backwards and undo the filling in of that road. And let's go back to our shape tool. And I guess we'll have to re-arc it here. Oh. Hitting 9 for the trace tool. Starting here, going to... Oh, hello. Okay, had to clear the whole trace out. So hitting 9 to get the trace tool. I'm going to start here. We'll arc over to here. Oops. I have clearly screwed up because now it's making straight lines instead of arcs. There we go. Actually, I think we want a... Yeah, we want an arc. Okay. Good. And we'll flatten it out just a little bit. And we'll bring it up a little higher than we did last time to avoid the thickness of the road hitting the top of the ship. All right. Make sure I've got regular road selected. I do. And then we'll hit 0 and just have it fill in the arc. Okay, good. It's not hitting this time. I'm zooming in and out with the mouse wheel, by the way. And if you have sort of no nodes selected, you can use hold down left mouse click and drag to move the whole map around. All right. That looks reasonably good. And I think we'll just do another Warren truss, another one of these triangular trusses. I'm going to hit 2 to get my wood out. And I've got auto triangulate on, so I think when I start going here, I can just do, just essentially carry on with this triangular truss right up and over the top of this rainbow-shaped arch here. All right. So, triangular truss, Warren truss, isn't necessarily the strongest truss you can do, and we may actually need a stronger type of truss to actually do this. Now, we have steel, so if we want to put steel reinforcing in here, we certainly can. The other thing is that some of these things seem just a little bit long to me. That's what she said. So I'm going to use hold down left shift, see how the cursor has turned into this sort of 4-arrow thing. And I'm going to use the hold down left shift and then left click and drag to move some of these longer pieces down and make them look a little shorter. You can see there's that football-shaped dash thing. That is the sort of zone where you can move this particular node and it'll still satisfy all of the structural constraints of connecting to the other things it's currently connected to. That's the sort of envelope within which you can move it. All right, I like that. That looks good. This is just a little weird to me, so I'm going to go ahead and shorten this up just a little bit. Again, holding down left shift, and then holding down left click and dragging. Okay. That seems like it's got a reasonable chance of success. Let's simulate it and see if maybe just the sort of more stressful nature of having an arch is causing more tensile or compressive load on any of these pieces of road. And let's just see if anything breaks. Oh! So, clearly, something is not strong enough here. I didn't catch what it was. It might have been this skinny little thing underneath the road here. Let's go back and look for any piece of the bridge that has a little red box around it. Aha. So it was this guy. So you can do a lot of different things to strengthen different pieces of a bridge, but in this case, this is such a small piece that I think probably the best thing to do is just replace this with a piece of steel. So I'm going to left click and drag to highlight that, hit D to delete it, and then I'll go over here and press 3 on my keypad to get steel. And I'll just build a piece of steel, just like that. Escape to stop building. All right, so this should be very, very strong now, and that's great. But the problem always is when you make one piece of a bridge stronger, sometimes that means that other pieces of the bridge may go over their stress limits, and this piece won't break now because it's stronger, but other pieces of the bridge are not any stronger than they were before, and it's possible that some other piece of the bridge may break now. So let's hit space to simulate this. So far, so good. Oh, yeah. Nice. So, no issues with the ship getting underneath here. And, you know, the maximum stress was only 61%, which is way more than fine for a video game. In real engineering, when you build a bridge, you usually have something called a factor of safety. And that means that you build the bridge some number of times stronger than it needs to be. In olden times, before they had computer simulation, to simulate the strength of materials and of designs, they frequently used a safety factor of 10. So you would build the bridge 10 times stronger than it needed to be, or 10 times stronger than you thought it needed to be. You were never sure, of course, because you were doing all the calculations by hand. But in this case, we have a safety factor of whatever 61% is. Is that like 0.7 maybe, or 0.65? So, you know, we're stronger than we need to be by a fair good margin for a simulation. You were building real bridges, you would probably want to have a safety factor of 5. So this would need to be maximum stress 20%, because 5 times 20% is 100%. But for a video game with a limited budget, this is just fine. Let's go on to the next level. So now they're introducing the checkpoint mechanic. And the checkpoint mechanic is a really interesting one because it means that certain vehicles have to touch certain stars on their way to their goal, which is their flag. So you can see we have car A1 here, we have checkpoint A1.1, and goal A1 here. So this car starts here, it has to touch this checkpoint, and it has to end up at this flag. Likewise, the Volkswagen here, which is A2, has to touch this star down here, A2.1, and then it has to end up at flag A2. Now, some of this is fairly easy because the top part of this is pretty much just the arching bridge that we built before, but a little bit longer. So let's tackle the easy part first. The car is lighter. It's just a little bit of an arched bridge just to get it high enough to touch that star. And then we'll worry about what we're going to do with this slower, heavier Volkswagen bus that has to dip downward in order to get to this bottom star. But let's do the easy part first. We'll test it, and we'll just ignore this guy for now. Whatever happens to him, happens to him. So let's hit 9 to get our curve tracing tool. And then we will start here and push an arc over to here. And let's see. Just for a second, I'm going to turn on the grid. So it looks like this guy is about 2 grid squares off the ground. 2.5 maybe. So we can bring our road, say, 2 grid squares below that star, and that car should still get that no problem. So, we'll start with that. That looks okay. We'll just get regular road for this one. So I'll just hit 1 to get regular road. Nope, regular road. There we go. And then if I hit the 0 key on my keyboard, it'll just send that regular road all the way over this established arc. Easy peasy. And because I'm lazy, and I don't want to build a fancier Pratt truss, Howe truss or Pratt truss looks like this. It has these squares in the center with these diagonals in it. Now, if the diagonals all go towards the top center, that's a Howe truss. And if the diagonals all go away from the center, then that is a Pratt truss. They're slightly different in terms of which members are in compression versus tension. In a Howe truss, these longer diagonals are in compression, and the shorter vertical slots are in tension, which is great when you're building with wood, which has greater compressive strength. The longer member, the one that will be weaker just because it's longer, you know, you're using wood's compressive strength well. However, in this particular polybridge level, I think we are still well within the strength of a Warren truss or triangular truss. So let's just do a wooden 2 on my keypad. And make sure that we have auto triangulate on with R. That's off. Dashed lines. If I hit R again, solid lines. Okay, and then we'll just truss this up with Warren truss. I'm going to turn off the grid. I don't like how the grid forces me to be at grid intersection. So hitting G to turn the grid off. And we'll just make these as big as we can at first. We'll come back later and move them around. And I'm just going to kind of have to do this by feel, more or less. Okay. Now we're coming down the other side, so top should slope down a little bit. All right, so this will probably work as it is first time, but just for a giggle, let's just simulate the car going up and over, touching the star and getting to its end, and sorry, surfer dude, but going in the drink. Stress is looking real good down here. Oh, got the star. Okay, so we saw the car hit that star right there. We know we've got the top bridge all set. So now we'll have to go and do the harder part, which is how do we get this guy down here? So, road is not great under tension, and if we just try to hit 9 on my keyboard to get the arc tool, we'll go arc here to here. We'll drag these down so that it goes, you know, just underneath here. Like if we just clip the edge of the star, we'll get it. So sure, why not? We'll do that. And let's just use reinforced road for this one, since there's going to be a lot more forces coming through here. You know what? Let's try it with regular road. I'm going to hit 1 to get regular road. Yep, that's regular road. And then I'm going to hit 0 to just whack regular road all the way through that whole arch. So, familiar story here, right? You already know what's going to happen. As the weight of this bridge pulls itself down, it's going to put tension forces pulling apart these pieces of the road. And so we've got to reinforce them in some way to, you know, make the whole thing work. And honestly, this is a place where I would probably resort to that Pratt or Howe truss that we talked about earlier, just because I do believe that this bus is heavier. Well, you know what? Let's just do the experiment. We'll use triangular Warren truss. Hitting 1 on my keyboard. Oops, sorry. Hitting 2 on my keyboard to get wood. And I'm making sure auto triangulate is on. And we'll just triangulate this up. I'll have to delete some stuff in a second here, but that's okay. So you know what? I think I'm going to do that trick I showed you guys earlier, where once you've got half of the bridge, you just copy... Well, let's delete these two. This is so annoying, dude. I screwed up when I put this in because I did not properly triangulate that. And now I believe if I hold left shift and move this node around... Yeah, so this node down here needs to turn lighter yellow for me to be able to put another piece of wood through there. So there we go. Just trying to make the top of that as straight as possible. Actually, since the road is curvy, why don't we make the truss curvy too? Why not? Okay. And then let's hit 2 on the keyboard to get wood. We've already got it. Okay. Now let's just use our hold right click and drag to copy all this. Hitting C to copy. Hitting F to flip it over. And now we've got a perfectly symmetrical bridge. We just need to put in this tiny little middle part. So hitting 2 to get the wood. Putting wood across there. So this is very interesting. I don't know if this is going to work or not. There's a lot of tension forces on the road here. And this Howe truss isn't necessarily going to do a great job of resisting them necessarily, so let's hit spacebar and see what happens here. Oh geez, that's bad. See how it's orange already? Oh yeah. So I don't think that we can move this up anymore. I just don't believe that we're going to be able to touch the star. The game said that this piece of road broke right here, and so we might just want to do the lazy thing, just replace this with a piece of reinforced road and see what breaks next. I'm sure one of the other sections will break. So 1, that's regular road. 1 again gets you reinforced road. So I'm sure one of the other sections of this bridge will now break because they're all sort of relatively weak. This one won't break because it's strong, but one of the other ones will. So let's just see what happens here. The good news is that the Howe truss, the triangular truss, is holding up quite well. So here's my bet. If these two have broken, because the bridge is perfectly symmetrical, that these two are also going to break. So first of all, let's delete this, hitting D on the keyboard. And then we'll put in reinforced road. And now I think we should just delete these two preemptively. And just reinforce them with reinforced road as well, because the bridge is symmetrical, and I believe that even though you're sort of starting, the van goes on here, it more heavily loads this part of the bridge as it's coming on, but I still think you're going to have almost an equal load as that thing transitions over to the other side. So now my guess is we're probably going to see these break, one of these two. I'm not sure which one. It kind of depends on how the van rolls onto the bridge, but let's just hit spacebar and see what happens. Yeah. All right. So obviously, the lazy way is that we just keep building, you know, more reinforced road. And I think for the purposes of this video, which is getting a little long, I think I kind of like to do that just so we can end the video after this. But one thing we also could do, if we were feeling a little less lazy, is we could try and build something underneath this with steel. Because steel is really good in tension, and you could make a really good tensile structure underneath this with steel, and you probably wouldn't need reinforced road. Here's the thing, though. Reinforced road is $400 per meter. Steel is $450 per meter. So if you're building a big structure with a bunch of triangles under this, it's probably going to end up being more expensive being built out of $450 per meter steel than $400 per meter reinforced road. All right. This will probably be the last build in this video. It's getting a little long. That's what she said. And so let's just try this and just see what happens. We'll see if this will work. If this works, we'll end the video after this and save the rest of this first world, world number 1, for video number 2 in this playlist. And that's going orange. And even a little bit red, but I think I saw the stress go up to 97%. Let's see what happens. Oh, 99.8%. Oh my god. That almost broke. It got so close. Alright, well, maybe in video number 2... Now, you know what? Fuck it. I am going to go full retard. Delete all this. And let's go steel underneath here. So first of all, we'll just do a piece of steel right there. And now, that is so strong in compression, there is no chance of any problem. And this node right here is going to be incredibly strong. And then let's just do sort of a bowstring type... Well, let's just mirror that over. There we go. And then let's do kind of a bowstring truss type of deal, where we just put a bowstring underneath this with steel. You can see I've got my automatic triangulation on, so it auto-triangulates. And I'm going to have to delete a couple of these. That one's okay. We'll just leave that how it is. Then we'll go here. And sort of... Okay. And then these two guys, I don't want them there, because what I'm going to do is I'm going to do that thing where I copy. So let's right-click and drag, I think. Oh, that didn't work at all. There we go. Copy that. F to flip it. And then we just need to put in this little guy right here. Alright. You know what? This guy, because this is really, really strong, we probably don't even need... Actually, you know what? We'll leave this here and I'll tell you why. because we're going to take out this reinforced road and put regular road in here, and trust to the strength of this steel. This guy provides a force that pushes inward, and that prevents tensile forces from happening on the road. So, delete all this. Right. And in fact, since we have a symmetrical bridge design here, let's just delete all that. Delete that. Well, actually, you know what? We're not going to. Just copy all this. C to copy. F to flip it. Trust that the game will eliminate the duplicate there. And then we're going back to number 1 for not reinforced. We're doing regular, so press 1 again. Bada bing, bada boom. Alright. I'm going to go ahead and predict this is going to work. Maybe I'll have to drag these down a little bit farther, but I doubt it. Steel is so strong, it's going to hold this up so well, and all these triangular pieces, they're very, very rigid, because it's really, really hard to move one point of a triangle. You'll compress one leg and tension the other, and steel is very strong in both compression and tension. So let's just run this by hitting space. Look at how, like, the little end pieces go orange on that bottom bridge. Let's go back. I just want to show you. I want to emphasize. We'll go down to 20% speed. And then we'll zoom in on the bottom here. This guy goes orange. This guy goes orange. Nothing else in this entire bridge is anything but green. This is an incredibly strong bridge. A little bit of orange there. 70% maximum stress, maybe. Now, we have used $21,854 of our $22,000 budget. So, clearly this is an expensive bridge, but it's a very, very strong bridge, and I'm very, very happy with the engineering that went into that bridge. So, I hope you enjoyed this video, this introduction to Poly Bridge. I'll be playing a lot more of this. There's going to be a whole playlist. Probably if you are watching this video sometime in the future, after May 1st, 2023, you can go to my channel, and in fact, if I do a playlist, I'll try and put it in the description of this video, so you could just click on the link to the Poly Bridge playlist in my channel. Although, of course, remember, there will also be a link to Real Civil Engineers Poly Bridge playlist too. So, hope you've had fun. Hope you've enjoyed this. They'll definitely be doing a lot more of this, and I hope that you are staying salty, my friends.